So, good evening, everyone. I hope my voice is clear. Can anyone confirm? Yes, no, about the voice? Hello. Am I audible? Right? Please, someone check. Hello. YouTube. I feel like I am audible. Hello. Okay. Fine. Let me first introduce myself. This is our first lecture. So, my name is Keval Parmar and I am a professor for mathematics. So, as today's our first lecture, and I hope you are familiar with what topics we are going to cover. But still, let me tell you, we are going to cover, we are going to start with relations and functions. So, relations and functions are two different things. Today, we'll try to cover relations, in which the subtopics are: first, we'll go what is ordered pair, Cartesian product of two sets, what is a relation, what exactly is the definition of a relation. Next is domain, range, and codomain, a very important part for relations, as we are going to need it in functions. And lastly, we'll study types of relations. Along with this, we will also go through some of the questions to better understand ourselves. Okay, so let's start. Welcome all. So first, I would like to just brief you about what are sets. I hope you are familiar with the knowledge of sets. So sets is basically we have studied in 10th standard, also in 11th standard. Before this chapter, you have studied. So let us dive into the topic and see what are the ordered pairs. Basically, you have studied ordered pairs from like starting from the sets, but here it is just given a name. Suppose, for example, here I can write, here as we can see, a pair A comma B of numbers, such that the order in which the numbers appear is important. That is called an ordered pair. You know how in Cartesian coordinate system we use points like a point 1 comma 2 on x-axis and y-axis. So similarly, this is also an ordered pair. So basic definition of ordered pair is same. Ki 1 comma 2 is an ordered pair. So here it says obviously such that the order in which the numbers appear are important. That means 1 comma 2 and 2 comma 1 are not the same. So next, that is what will bring us to the second statement, which goes ordered pairs A comma B and B comma A are different. That is what I just explained. As we all know, in the coordinate system XY plane, 1 comma 2 and 2 comma 1 are different. And in ordered pair, let us go some to technical terms. The first number, which is A, is called the first component and B is called the second component. These technical terms are important because sometimes in question they use these terms. So we must know what is the first component and what is the second component. So let us solve very easy example like find x and y when this is the ordered pair and this is the ordered pair. So if two ordered pairs are equal, let me show you. A comma B is equals to C comma D. What this means is that A is equals to C and B is equals to D. The first component is equals to the first component. The second component is equals to the second component. So here it is very simple. Let us just equate the first components. So from here, I guess the first component is x plus 3. will be equal to 4. So what will I get the value of x as? X equals to 4 minus 3. That means x is equals to 1. Similarly, if we equate the second component, 2 is equals to y minus 3. So 2 plus 3 will be equals to y. So like my second component, y will be equals to 5. This is my answer. Very simple, very easy to understand. X is 1 and y is 5. So I hope ordered pair is clear, very clear. Now, do you remember what was the next topic we are going to do after ordered pair? Here, it is Cartesian product of two sets. Now, here where the real chapter or where the real meaning of relation starts. We'll define relation in some time, but these are the prerequisites, ordered pair and Cartesian product of two sets. So Cartesian product of two sets is a very simple thing. Let me tell you what is a Cartesian product. Suppose A and B are two sets. Any sets A and B, then the Cartesian product of A and B is denoted by A cross B. Like if I want to find Cartesian product of A and B, it is denoted by A cross B. And it is defined as set of all ordered pairs. Basically, this means a Cartesian product is also a set, but it is not a normal set. It is the set of ordered pairs, such that A, small a, is an element of set A and B is an element of set B. Do you understand? I hope you are all getting it. A cross B means it is a set. It is a set of ordered pairs where the first element A is from set A and the second element B is from set B. Now let us take a very simple example. So we'll take this example. You'll be more clear of what is a Cartesian product. So suppose it is given set A has two elements, 1 and 2, and set B has three elements, A, B, and C. Then I have to find A cross B. A cross B means Cartesian product of A and B. So let me tell you, A cross B will be equal to a set. It will be a set of all the ordered pairs where the first element in the ordered pair will be from set A and the second element in the ordered pair will be from set B. So if I want to make different combinations, then how many combinations will be possible? Let us say if I take first element 1 here and second element I have to take from B. So one of the ordered pair will be 1 comma A. Sorry, this is comma. Please ignore my handwriting. Now, if again I take A, then second from B. If again I take 1, then this is C. Now, I hope you are getting it. So, here again, now all the combinations for 1 are over, which is 1A, 1B, 1C. Now, similarly, we can do for 2. It will be 2A, 2B, and 2C. So this is a set. A cross B is a set of all ordered pairs. 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B, 2 comma C. Now, if someone asks you, what are the number of elements in this ordered pair? Let me ask you a very simple question. In set A, how many number of elements are present? And there are 2. In set B, how many number of elements are present? There are 3. Now, similarly, can you tell me how many elements are present in A cross B? In this Cartesian product, 1, 2, A cross B, the number of elements are 6. So this was a very simple example, but in most of the cases, A will not have 2 elements. Suppose A has 10 elements and suppose B has 20 elements, and someone asks me to find the number of elements in A cross B. So can you tell me how it came? It is very simple. We just multiply 2 and 3. So if I do 2 into 3, then I will get 6. So this is how we find the number of elements in Cartesian product. It is same is written here. If number of elements in A are m, number of elements in B are n, then the number of elements in the Cartesian product will be just multiply these two, m into n. So again, let us understand it more clearly with the help of this example. It is like very similar example, but just for understanding. A has how many elements? Number of elements of A are 2. B has how many elements? Number of elements of B are 3. Then number of elements in Cartesian product means n of A cross B. A cross B is the notation of Cartesian product. Will be 2 into 3, just multiply, which is equal to 6. So my answer is 6. Now, let me show you another some. Let us go through more questions. This. Next is a Cartesian product of a set with itself. This is the last part before we dive into the main definition of a relation. So Cartesian product of set with itself. Till now, if you see, we were taking Cartesian product of A and B, means A cross B. So now if I want to take a Cartesian product of set with itself, means A cross A. So here it is also a set of ordered pairs, but if it is A cross A, then first element should be from A and second element should also be from A. So here it's very simple. Last May, what was the last time? Last time the first element was from A, but the second element was from B. Here the only difference is the first element and the second element. Both are from A. So let us find how many combinations we can make. First, if the first element is from A, so I'll write 4. Second element also from A, 4. Then I can write 4, 5. Then I can write 5, 4, and lastly 5, 5. So this is my A cross A, Cartesian product of a set with itself. So here I can say Cartesian product of A with A itself. I hope you are getting it. Now this logic can be extended into many Cartesian products. So here I have written A cross A cross A. Meaning, if you are getting it, the ordered pair will have 3 elements. First element will be from A, second element will be from A, and third element will also be from A. So, can you guess how many combinations will be possible? Okay, let us do it simultaneously. So, if I take first element from A, then it will be 4, second from A, 4, and 5. Next, it can be 4, 5, 4. And I think lastly, it will be 5, 4, and 4. So I hope no other combinations remaining. Please, you also check and let me know in the chat box if other combinations remaining. 4, 4, 5, 4, 5, 4, 5, 4, 4. I don't think any other combinations remaining. So this is the Cartesian product of set with itself, but it is 3 times A cross A cross A. So let us go once again. What is a Cartesian product? Cartesian product is a set of all ordered pairs, where first element is from the first set, second element is from the second set. I hope we are clear with ordered pair and Cartesian product, because relation definition is based on Cartesian. So now it is time for understanding the meaning of the heading of the chapter, which is relations and functions. So let us dive into what is a relation. Now, a relation is basically like what we spell in English, a relation between father and son. What is the relation between father and son? Like you are related with blood, you are your father's child, and so on. So this is relation. So same meaning applies here, but we just don't have father and son here. We just have relation with numbers. Relation with numbers. So let us dive into the definition. As it is maths, we always talk about numbers. You have talking about numbers since school. So yeah, what is the relation? As I was saying, members in a family are often related to each other. We describe relation as A is a friend of B. Suppose I don't know who are A and B. F is a father of S. P is a sister of Q, and so on. So the relation word has the same meaning, just the content is different. Instead of people, here we use numbers. So in mathematics, we can have different relations. Now, let us dive into what types of relations we have in mathematics. So let us study among integers. I hope you are familiar with integers. 0, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4. Those all are integers. We can define a relation. Let me define a relation as m is a factor of n. Meaning, if I factorize completely, suppose let me factorize the number 10. So if I factorize 10, first I'll write 2, here it's 5, then 5, and finally I'll write 1. I hope you also factorize like this. So 2 and 5 are factors of 10. So I have defined a relation as m in general is a factor of n. So let us now denote this relation. We denote this relation by r. Then we can write this is a symbol for a relation. Please note this is a symbol for relation. 2r4, meaning r is defined as m is a factor of n, meaning 2 is a factor of 4. 2 is a factor of 4. Basically, I can say कि 2 4 के टेबल में आता है. 2 4 के टेबल में आता है. I hope no, I said it उल्टा, right? 4 2 के टेबल में आता है. Sorry, 4 2 के टेबल में आता है. Similarly, 3 is a factor of 6, meaning 6 3 के टेबल में आता है. 3 1s are 3, 3 2s are 6. 5 is a factor of 10, meaning 10 5 के टेबल में आता है. 5 1s are 5, 5 2s are 10. So this is how we define relation between numbers. We can define infinitely many relations, as we all know. Now, let us go through some notations. We have gone through these notations. 2r4 means 2 is a factor of 4, depending on what r is defined as. So this is a notation. A well-defined relation between elements of A and B is given by A R B. We already saw 2 and 4. Beech mein khali we have to put R, where A belongs to set A and B belongs to set B. Now, this means if we go into technical definition of relation, as we have already studied ordered pair, we can easily say that relation also gives an ordered pair A comma B. Like for here, I can write the ordered pair 2 comma 4. What will I write here? 3 comma 6. And here 5 comma 10. So relation is basically a set of whose set of these ordered pairs. Now, if relation is also a set of ordered pairs, and do you remember Cartesian product is also a set of ordered pairs? Relation and Cartesian product, both are sets of ordered pairs. So what is the difference between the two? The difference is the relation is a subset of the Cartesian product. I hope you are familiar with subset. Subset मतलब एक तो कोई बड़ा सेट है, उसमें से छोटे छोटे पार्ट्स we remove. So these are called subset. Let me go walk with very simple example. If a set is 1, 2, and 3, and A has elements 1 and 2, so I can say A is a subset of S. A is a subset of S. Why? Because A has 1 and A has 2. So similarly, difference between relation and Cartesian product is that relation will always be a subset, uska chota bhai jaisa, like a little brother, younger brother of Cartesian product. So to understand it, let us see an example here. There are two sets given, set A and set B. Then the relation ARB, A is related to B. And what is relation defined as? A is a factor of B, same, A is a factor of B. Then R is a subset. If A is a factor of B, meaning the first element should be of A, second element should be of B. So yeah, 2 is a factor of 6, मतलब 6 2 के टेबल में आता है, 2 3 जा 6, 2 is a factor of 8, मतलब 8 2 के टेबल में आता है, 2 4 जा 8, 10 2 is a factor of 10, similarly 3 is a factor of 10, 4 is a factor of 10, and 5 is a factor of 10. So from these two sets A and B, we got this relation which satisfies the definition of that A, first element, is the factor of the second element. So as you can see, if this is clearly a subset of Cartesian product A cross B. Now, I will not write the Cartesian product of A cross B because as we all know, there are 1, 2, 3, 4, 5. 5 elements in A and 1, 2, 3, 4. 4 elements in B. So if there are 5 elements in A and 4 elements in B, then how many number of elements will be there in the Cartesian product? We just have to multiply both. So 5 4s are 20 elements will be there in the Cartesian product A cross B. So I am not going to write the 20 elements. I just need you all to visualize key out of those 20 elements, the 6 elements will be these. Out of those 20 elements, the 6 elements will be these: 2, 6, 2, 8, 2, 10, 3, 6, 4, 8, and 5, 10. I hope you are all clear. I'll give you 10 to 20 seconds to visualize if these 6 elements come in the 20 elements of the Cartesian product. Everyone please see on the screen and just try to visualize. Okay. So let me I'll show you, you just have to imagine. The Cartesian product elements of A cross B will be 2, 6, 2, 7, 2, 8, 2, 10. Next, same for 3, 3, 6, 3, 7, 3, 8, 3, 10. Same for 4, 4, 6, 4, 7, 4, 8, 4, 10. Same for 5, same for 6. So this will help you in determining that this relation is a subset of A cross B. Yeah, so relation is basically a subset of Cartesian product, but Cartesian product does not have some specific relation between the numbers. Here we have relation between 2 and 6. 2 is a factor of 6, मतलब 6 2 के table में आता है. But in Cartesian product, there is no relation between those two numbers. So you can say that a relation is a special case of Cartesian product. This will help you to visualize easily. A relation is a special case of Cartesian product in which some elements are picked which have some relation between them. So yeah, I hope the definition of relation is very clear to you. So then we'll move forward. Okay. There is one more example I would like to solve. I would like you all to solve with me, which is, let A, there are two sets A and B, and let us now get a relation R, where R is defined as, obviously it is a set of ordered pair x, y, and x should be less than y. If it is a set of ordered pairs x, y, then I have to pick x from set A and I have to pick y from set B. Okay? But this should I have to pick x and y such that these conditions are satisfied, which is x is less than y. So can you give me first element from A? If I take 1, then I need to take your number which is greater than 1. Then it will satisfy x is less than y. But that number should be from B. So I cannot take 1 here. I need to take 4. Another one is possible is 1, 5. See, 1 is from set A, 4 and 5 are from set B. So this is done. And x is less than y. 1 is less than 4, right? 1 is less than 5, right? So basically, I am just forming a relation by the definition they want. So there are some more which we can form ordered pairs. If I take 2, then again I can write 2, 4 and 2, 5. Then if I take 3, then I can again write 3, 4 and 3, 5. Now let us see, if I take 4, then I cannot take 4 here from this. So I cannot take 1, I cannot take 4, but I can take 5. And if I take 5 from A, I cannot take 1, cannot take 4, cannot take 5. Means 5 wala is not possible. So this is my relation. This is my relation. Let me just rub this. Yeah. So my relation now formed is this. 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5, and lastly 4, 5. Now, can you tell me number of elements in this relation? Let us count together. 1, 2, 3, 4, 5, 6, 7. So, number of elements in this relation are 7. Okay. Now, let us talk about Cartesian product. If I need A cross B, then can you visualize A cross B? It will be 1, 1, 1, 4, 1, 5, 2, 1, 2, 4, 2, 5, 3, 1, 3, 4, 3, 5. Same for 4, 1, 4, 4, 4, 5, 5, 1, 5, 4, 5, 5. Now you have to now understand that this big set of A cross B has a subset which is R. So I will not write the whole set. Just tell me the number of elements in A cross B. Number of elements in A are 5 and number of elements in B are 3. So number of elements in A cross B will be 5 into 3, which is 15. I hope this is clear. Now, next, after understanding what relation is, let us go to the very, very, very important part. Like, I would like you to remember this part from this lecture very thoroughly, which is domain, codomain, and range. Domain, codomain, and range. If you want to remember, if you want to point out the most important part from this lecture, it is this domain, codomain, and range, because this is very important and many questions come from this. So let us define domain. As you all can read, what is a domain? The set of all the first components of the ordered pairs in the relation R is called the domain of the relation. Meaning, if I write a relation 1, 2, if one of the ordered pair in my relation is 1, 2, then the first component 1 will come in my domain. And what is range? Range is the second component. The second component 2 will come in my range. So I hope domain and range meaning is very clear to you. The first component will be a domain, second component will be the range. We just have to form sets of first components in all ordered pairs and second component in all ordered pairs, so that we'll get domain and range. Then what is codomain? Now codomain has very interesting definition, which is If R is a relation from A to B, like if R is defined from set A to set B, then the whole set B is called the codomain. Then the whole set B is called the codomain. So for you not to be confused between range and codomain, let me tell you that range is always a subset of codomain. Like I will pick up the second elements from second set, that is here, the second elements will be picked from set B. So it is possible that all the elements of set B will not be in my relation. Obviously, na? All the elements of set B will not be in my relation. So that means there will be only some elements will be there in my relation from set B, and those elements are range. But the entire set B with those elements and with the remaining elements will be my codomain. Now this will become very clear. It's very simple if we take just an example. Just remember, range is always a subset of codomain. इस codomain में से उठा के हम लोग range लेंगे. जैसे how relation is a subset of Cartesian product. Similarly, range is a subset of codomain. So let us take an example. Here, a relation R is given and some ordered pairs are given. I am asked to find domain and range. So domain is generally defined as capital D, which will be the set of all the numbers which comes first. Here, the numbers which come first are 1, 1, 3, and 3. So I hope you remember, in sets, we never repeat the numbers. So in sets, I cannot write 1, 1, 3, 3. No, it's not possible. It's not allowed to write the sets in such a way that numbers are repeated. So I can simply write 1 and 3. DR. What this subscript R denotes? Domain of the relation R. Domain of the relation R. So range of R will be the set of second element. Second elements are 2, 4, 2, 4. So again, I no need to repeat it. It will be 2, 4. So this is the domain and this is the range. I hope you are clear. Chalo. Let's move on to the next part. Again, these are some questions. Let A and B. There is set A given, set B given. Both have 3 elements. And I have a relation 1, 2, 1, 4, 3, 2, 3, 4. And I have to prove that relation, show that relation is a relation from A to B. Like R is defined from set A to set B. I have to show that. So if I want to define relation, if you remember, relation is defined as a subset of the Cartesian product. So if I try to write Cartesian product of A cross B, what will it be? 1, 2, 1, 4, 1, 6, 1, 2, 1, 4, 1, 6. Then 2, 2, 2, 4, and 2, 6. And lastly, we'll have 3, 2, 3, 4, and 3, 6. This is my Cartesian product A cross B. Now, as we clearly see that this Cartesian product has 1, 2, 1, 2. I am showing that the relation is a subset of Cartesian product 1, 4, 1, 4, 3, 2, 3, 2, and 3, 4, 3, 4. So from the Cartesian product, only 4 elements are there in the relation R. So this means, clearly means that R is a subset. This is a symbol for subset of A cross B. And if R is a subset of the Cartesian product, meaning R is a relation from A to B. Now here comes the interesting part. we have to find domain, codomain, and range. So the domain of R, which is dr, is set of all elements from R which comes first. Which elements comes first? This is 1, 1, 1, 1, 3, 3. Means domain of R is 1 and 3. What will be the range of R? Range of R will be second elements 2, 4, 2, 4. Means 2 and 4. Now here comes the interesting part. What is the codomain? If you remember the definition of codomain, if a relation is defined from set A to set B, then the whole set B is my codomain. Here again R, the first elements are from set A, second elements are from set B. Means R is defined from set A to set B, meaning my codomain will be nothing but entirely set B, which is 2, 4, and 6. And here, the thing that I have been saying, the range is always a subset of codomain is clear. Why? Range is 2 from codomain and 4 from codomain. Similar to this, I can say range is a subset of codomain. I hope this example is very clear to you all. Now, there is one relation like how we studied Cartesian product of a set with itself, like A cross A. Then we studied A cross A cross A 3 times. I remember. Just let me get back to you this slide. A cross A. This is a Cartesian product of set with itself. So based on this, there is a relation, there is a definition, special type of relation, which is known as binary relation. Binary relation means, basically, let me tell you again, relation is a subset of Cartesian product. If a relation is from set A to B, then the relation will be a Cartesian subset of the Cartesian product A cross B. But here, binary relation means that the relation will be a subset of A cross A. Relation will be a subset of A cross A. That is, the first element will also be from A. The second element will also be from A. So this is very simple definition known as binary relation. Now let's see the example. Obviously a set is given, which is set A, which is 1, 2, 3. Now I have to check if R is a binary relation on A. It is same as last question. I just have to get the Cartesian product of A cross A. And if I prove that this relation is a subset of A cross A, then this means this is a binary relation. So let us find the Cartesian product of A cross A. It will be 1, 1. First element also from A, second element also from A. So 1, 2, 1, 3. Then 2, 1, 2, 2, 2, 3. And lastly, we'll have 3, 1, 3, 2, and 3, 3. Okay. Okay. 1 second. Let me just put comma. Now I just have to see that whether these all elements, these all ordered pairs come in the Cartesian product. So 1 cross 2, yes, 1 cross 2, 2 cross 2, yes, 2 cross 2, 3 cross 1, yes, 3 cross 1, 3 cross 2, 3 cross 2. So as we can clearly see that all the elements in R are picked up from A cross A, meaning R is a subset of A cross A, meaning if R is a subset of A cross A, then by definition, R is a binary relation. Binary relation on set A. So I hope the binary relation example is very clear. Okay, moving on to next. Now, relations, definition and all the like basic water relations and all we have understood very easily. If you have any doubt, you can ask. Also, I would like to now go through, I have prepared some 2 questions. This is the first one. I would like you all to try first, like just get a gist of the questions, like how the question comes, what does they mean. Okay. So yeah, this is the question. Just understand the question first. There are 2 sets given, set A and set B. We have done this question, so not to worry. R is a relation from A to B. Now, if R is a relation from A to B, this is a very important statement. What I conclude, let me tell you how I think about this statement. So then you can, take an idea. If R is a relation from A to B, meaning that my first element should be from set A and the second element should be from set B. And the other important thing, B is the codomain. Think about it. B is the codomain. So these 2 things are very clear. Now, they have defined R, what R should be. R should follow this definition. 2x should be less than y. Means the first element x should be from A, second element y should be from B, and this should satisfy the condition twice of x is less than y. So now let us try. List the elements of R. First question. How will R look like? How will R look like? Suppose x I take it 1 and from B I also take it 1. So listen to me very carefully. Please, everyone. So this is the value of x and this is the value of y. So does this satisfy 2x less than y? I guess yes, this satisfies. Because 2 into 1 is 1. Oh, sorry. 2 into 1 is 2. 2 into 1 is 2 and 2 is less than 1. So yeah, this will be my relation. Then I can also write 1, 4. Please let me know if I make a mistake. Please take 1, 4. Yes. Twice of 1 should be less than 4. Please listen very carefully how I read this. Twice of x should be less than y. Twice of 1 should be less than 4. Yes, it is true. I can also write 1, 5. Twice of 1 is less than 5. Twice of 1 is 2 and 2 is less than 5. Yes, very good. Now I am done taking 1. Now I'll take 2 from A. So twice of 2 should be less than this, what I'm going to write here. So twice of 2 is 4. So here 4 is less than. 4 is less than not 1. 4 is less than not 4. 4 is less than 5. So I have to write here 5. Twice of 2 is less than 5. Twice of 2 is 4. 4 is less than 5. Now think if I take 3. Twice of 3 is 6. And there is no element in B which is less than, which is greater than 6. See, 6 is not less than 1. 6 is not less than 4. 6 is not less than 5. Okay, so I cannot take 3. Similarly, I cannot take 4. Similarly, I cannot take 5. So yeah. Okay, someone pointed out that I made a mistake. Thank you, thank you. See, that is what I was talking about. They are telling, he said, 1, 1 will not come. Yes, absolutely right. Sorry for this. 1 will not come because twice of 1 is not less than 1. Twice of 1 means 2. 2 is not less than 1. Thank you so much. Yeah. So this is also a check that you all are paying attention. Thank you. I was just joking. Very good. 1, 1 will not come. So my relation is 1, 4, 1, 5, and 1, 6. Let me write this in proper way. R will be equal to this. Now, second is very simple. Find the domain, codomain, and range. So domain of R will be the first element from R, which is 1, 1, and 2. So that means 1 and 2. Range of R will be second elements. Second elements are 4, 5, 5 means 4 and 5. Now, as we already defined codomain here, that is codomain is a set B. So codomain is the set B, which is 1, 4, and 5. So yeah, both of my questions are done. Now this is a similar question next. Let us go through this. This is a question on binary relation, if you know what I mean. Because only one set is given A, and I have to define relation from A to A. Means first element will be from A, second element will also be from A, and the relation is defined as x comma y. I have to pick x from set A, I have to pick y from set A. So that to satisfy this condition, y should be equal to x plus 1. And again, same, we have to write domain, codomain, and range relation x comma y. How I read this? See, I read it as y should be equal to x plus 1. Means if I add 1 in x, I should get y. So if I take x as 1, if I add 1 in x, if I add 1 in 1, I should get y. So I'll get 2. So 1 comma 2 is the valid. If you are not sure, then this is x, this is y. Check this condition. Y is 2 and x is 1. So this is a true relation. 2 equals to 1. So similarly, and y should be 1 plus 2. Which in 1 here, this is 1 greater means 2. If I take 2 here, this is 1 greater means 3. So if I take 3 here, what will be this 1 greater? This will be 4. Now if I take 4 here, this will be 5. If I take 5 here, this will be 6. If I take 6 here, this will be 7. 7 will not be possible because the first and second element should be from set A. Here 6 is from set A, but see 7. There is no 7 here. So we have to stop here. Again, so basically my relation will be 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. Okay, I hope you got this. And now we have to define domain. Domain means the first elements. First elements are 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. Correct. Range. How I define range? 2, 3, 4, 5, 6. So 6. Now let's talk about codomain. If a relation is defined from A to A, then the second set is my codomain. Means your codomain is basically 2, 3, 4, 5. I enjoy actually solving questions in maths. Let it be of any chapter. Once we get an answer, we get so happy that yes, I got the answer. So now last part, it is like end of the lecture. So we'll just recap and we'll first look at what is the last part, which is types of relation. Basically, these types, reflexive, symmetric, and transitive, is from types of binary relation. So let A be a set, then binary relation on A. Binary relation R on A is said to be reflexive. Reflexive meaning A comma A should belong to relation R. This subset A comma A should belong to the relation R for every, obviously, for every A belongs to A, meaning if R is binary relation on A, means R is defined from A to A. This is not the notation. Let me write down. R is defined from A to A. Means first element is also from A, second element is also from A. I hope you are getting it. So basically this means that first element and second element both should be from A. So if such elements are such ordered pairs are present in R, that means it is a reflexive relation, symmetric relation. Do you know what this symbol means? This symbol? We read this symbol as implies. Implies. So this means that if A comma B belongs, means if A comma B is a ordered pair in relation R, implies B comma A should also be an ordered pair which belongs to relation R. That is, if 1 comma 2 is present in the relation, then 2 comma 1 should also be present in that relation. If these both are present, then we can say the relation is a symmetric relation. And what is transitive relation? And what is transitive relation? Transitive relation is if A comma B is present in relation and B comma C is present in relation, then A comma C present in relation, meaning it is a transitive relation. Let me go through this with an example. If say 1 comma 2, 2 comma 3 and 1 comma 3 are present in the relation, A comma B is present, B comma C is present, and A comma C is also present in the relation. If these all three elements are present in the relation, this means I call the relation as transitive relation. So it's very simple. सबसे simple is reflexive. Means 1 comma 1 should be present. Like if both the elements are same and are present in the relation is called reflexive. If reciprocal 1 comma 2, 2 comma 1 are present, then it is symmetric. And 3 times 1 2 2 3, then 1 3 is present, then they are transitive. And if a relation is all of these, that is, it is reflexive as well as symmetric as well as transitive. And such relation is called, and relation can be reflexive, a relation can be symmetric, a relation can be transitive. Then all these three relations are together all called equivalence relation. Okay, so these are the types of relation. As we are very close to our time, we would not be able to see like solve questions on these, but it's okay. It's very simple. Okay, someone is saying slide 5. Okay, slide 5. What is slide 5? Slide 5 is a definition of the relation. What is the relation? We define the relation. Relation is basically what? Relation between two numbers. Like 2 and 4. 2 and 4 are related as 2 is a factor of 4. 4 2 के टेबल में आता है. You know? And relation is always, like technical definition says, the relation is a subset of Cartesian product. If a relation is defined from set A to set B, then that relation will always be a subset of Cartesian product A cross B. Very good, very good. 6,6. Why not? I didn't understand. You are asking doubts. That are very good. Here in the example 6,6. Here we are not defining 6,6. Like 6, will be in the Cartesian product. You are right. 6, 6 will be in the Cartesian product. Okay, you are saying, oh, got it, got it. Here, A is a factor of B, meaning 6 is a factor of 6. Yeah, got it. Right. 6 is a factor of 6. So yeah, this is a 2, 6, 2, 8, 2, 10, 3, 6, 4, 8, and 6, 6 is also meaning 6 के table में 6 आता है. 6 is a factor of 6. But let me tell you, yeah, we can include 6, 6, right? Very good for you to point it out. Basically, if okay. So yeah, 6 is a factor of 6. Any doubt till now? I hope this is clear. We should also include 6, 6 here. Thank you. Chalo. Shabash. I hope you all make the classes more and more interactive as we go on. Today, I got quite 2, 3 interactions. I hope we'll get some more as we proceed. So I hope what is the meaning of relation is clear. Next time, if you know the topic, the heading of the chapter was relations and function. So next time means tomorrow only, we'll dive into what are functions. We are done with relations. Functions में से एक चीज I would like you to pick up is this again, domain, range and codomain of a function. So yeah, we'll end it here. I hope you all understood something from this lecture and would like to attend tomorrow's lecture. Okay, I'll end this meeting here. Thank you all.